Elon Musk organized a ceremony for the inauguration of his space company.
At the party, we'll burst such a rocket bomb that the whole city will know that not Musk, but Mast is the real rocket man.
The scientist brought the rocket.
How high will this go? Sir, its total weight is 20 kg, out of which 10 kg of fuel will be used to take it upward. It is designed such that 1 kg of fuel burns every second, generating a thrust of 250 Newton. I understood everything. Due to gravity, a 200 N force will act downward on the rocket. And due to thrust, 250 N will act upward, so the net force upward will be 50 N. Using F equals ma, the rocket's acceleration will be 5/2 meter per second squared. Now, since the fuel is 10 kg and burns at 1 kg per second, this acceleration will act for 10 seconds.
By putting values into the equation of motion, Elon Musk calculated the distance as 125 m.
But, sir, there is a mistake in this. Yes, I know. The thrust will end, but from this equation of motion, the rocket will still have a velocity of 25 meters per second, which means it will go 31.25 meters further up before stopping, making a total of 156.25 meters.
Musk didn't wait or think further and launched the rocket. But what's this? The rocket kept going higher and higher. It went so high that its explosion wasn't even visible at all.
What happened? Did we put in extra fuel? Sir, that's exactly what I was trying to tell you. In your calculation, you assumed the rocket's mass to be constant, but as the fuel burns, its mass keeps decreasing. Because of this, the gravitational force decreases, and the net upward force increases. Therefore, the rocket's acceleration keeps increasing.
So does that mean the equations of motion won't work here?
They will, sir, but for every moment, a different acceleration will have to be written on the equation. So how will we solve so many equations?
Due to the burning fuel, the rocket's mass will decrease by 1 kg every second, and the gravitational force acting downward at any time will be the rocket's mass multiplied by g. If we subtract gravitational pull from thrust to get the net force, and divide it by the rocket's mass, we get the rocket's acceleration equation. Notice that with time, the denominator decreases and the numerator increases, meaning the rocket's acceleration increases as it goes up.
Oh, that's why the rocket went higher. But exactly how high did it go? Sir, brace yourself. Calculus is going to be used.
Before distance, we'll have to find velocity using the first equation of motion, which can also be written in this integral form. If acceleration is constant, this equation converts into the normal form. But in our case, acceleration is a function of time and the initial velocity is 0. So this integral equation for velocity will be formed. Now, if we integrate this equation from the launch time to any time t, we will get the rocket's velocity at that time. And by integrating this velocity again, we will get the rocket's height. Since the fuel burns for 10 seconds, by putting t equals 10 here, we can find how high the rocket went after 10 seconds and what its velocity was at that point.
Why are things so complicated in real life?
But also see that if you know integration, how many real-life problems become so easy. Can you solve these equations?